Have you ever wondered why all planets are perfectly round? And what if these celestial bodies decided to break the rules and change their shape? Would we end up with square planets, triangular moons, or maybe even intergalactic shapes we can't even imagine? Well, let's find out. So how do planets form in the first place? The universe is filled with swirling clouds of dust and gas. These clouds, called molecular clouds, consist of various elements and compounds, such as hydrogen, helium, carbon, oxygen, and so on. They're like a cosmic kitchen filled with the ingredients needed to cook up some brand new planets. The first step in the recipe for planetary formation is called the accretion theory. Let's say that something happens that causes gravitational instability, like a supernova goes off nearby or something. This pushes the gas and dust in the cloud and causes them to come together. Because of gravity, these particles start falling toward a central point. They become more tightly packed together, like when you squeeze a ball in your hand. And eventually, they're squeezed so hard that the cloud starts to flatten into a disc shape, kind of like when you mix flour and water to make pizza dough. This disk is called a protoplanetary disk. It's also spinning because the cloud's particles had some rotation to begin with. Now, imagine these tiny dust particles and gas molecules dancing around in the disk. Sometimes they bump into each other, and when they do, they stick together like Velcro. These little clumps of dust and gas are called planetesimals. They're the building blocks of planets. And as the planetesimals continued to collide and merge, they grew larger and larger, forming protoplanets. The protoplanets were getting serious about their size, and their gravity became stronger. Some of them got so massive that they became the grand masters of their cosmic neighborhoods, the planets we know and love. Each planet had its own unique recipe of gases, rocks, and sometimes even water. But why do the planets look like spheres? Well, it's all because of gravity. Let's go back to our protoplanets. Imagine you're squeezing a balloon with your hands. The air inside of the balloon pushes back, creating pressure. Something similar happens with planets. Gravity squeezes its material inward, pulling in towards the center. And since gravity acts equally in all directions, it pulls material from all sides toward the center of mass, resulting in a sphere-like shape. And that material pushes back with pressure, resisting the force of gravity. In the end, they both find a sweet spot where they balance each other out. It's called hydrostatic equilibrium, a fancy term that means everything inside a planet is in balance. But that's not all. Another thing that makes the planet spherical is their rotation. Think about a ball of Play-Doh or something like that. Imagine you spin it rapidly. The material starts to push outward, making the Play-Doh bulge at the equator and flatten at the poles. The same thing happens to planets. As they spin on their axes, the combination of gravity and rotation pushes the material outward, making the planet bulge at the equator. They low-key want to become disks again. However, gravity doesn't want any lumpy planets. It wants them to be nice and round, so it keeps pulling on the material, trying to make everything as compact as possible. Eventually, gravity wins, and the planet settles into a spherical shape. Let's take some examples from our planetary playlist. Jupiter, the giant of the solar system, loves to show off its oblateness. It spins so fast that it becomes noticeably squished at the poles and chubby in the middle. It's like a spinning top with a cute belly. Saturn, the ringed wonder, also joins the oblate party. It spins around with its beautiful rings, and its oblateness is even more pronounced than Jupiter's. These examples show how rotation can give planets a unique shape. They go from being perfectly round to having a delightful bulge around the middle. It's like cosmic pottery, where the spinning motion creates a playful and distinct shape. So now you know why the planets are round. But what's more interesting is, what if they weren't? What if they were, let's say, cubical, or even triangular? Well, let's see. A cube-shaped or a triangle-shaped planet would have its mass spread out in a completely different way than a sphere. And you know what that means? Gravity would be all shook up too. On a spherical planet, gravity pulls everything towards the center because the mass is evenly distributed around that center. But when we introduce a cube-shaped or triangle-shaped planet, things get interesting. If you're standing at the center of one of those faces, you'd feel the strongest pull of gravity. That's because the faces are the closest to the center of gravity. And as you venture away from the center and start walking towards the edges, gravity starts playing tricks on you. You would feel the struggle against the steep angled gravity. Walking on those edges would feel just like climbing a mountain or walking on a super steep slope. All because gravity wants you right in the middle of the face and nowhere else. Now imagine the terrain along the edges and corners. It's a barren, rocky, and dry landscape. Why? Well, all the water would pool in at the center of each face, leaving the edges high and dry. And the air quality? Well, it's either non-existent or so thin that it can't support life. Not the coziest place to set up camp, that's for sure. And don't forget your warm clothes, lunch, and hiking boots. You'll need them because of the crazy climate. The type of climate you'll encounter on our cube or triangle-shaped Earth depends on how it spins. If it rotates at its corners, each side would enjoy a mild, temperate climate. However, if it rotates on an axis through two of its faces, things get intense. Picture a roller coaster version of our current climate. Some faces would be polar wonderlands, icy and chilly. The top and bottom faces for the cube, and the bottom face for the triangle. Meanwhile, the other sides would be completely different. In a cube, they would be scorching hot with an equatorial climate that would make you break a sweat. Instead of sunlight gently curving along the surface, it would directly beam onto these faces. Talk about feeling the heat. And on a triangular planet, the sunlight would strike the faces at an angle. This angled sunlight would create fascinating temperature variations across the planet. Imagine this. As you move from the base of the triangle towards the tip, the temperatures would gradually decrease. The base, where the sunlight hits most directly, would be the hottest region, just like the equatorial climate we're familiar with on our spherical Earth. But as you venture towards the tip, the angle of sunlight would be less direct, leading to cooler temperatures. But the base is still super cold and dark, since the sunlight doesn't directly reach it. So the triangle would be absolutely crazy in terms of temperature changes and climate zones. By the way, you know that cozy blanket of air we call the atmosphere? Well, on our angular Earth, things would get a little topsy-turvy. Gravity would be pulling stronger from the center of each face. The result? The atmosphere would go through some crazy changes. Picture this. At the center of each face, where gravity is strongest, the atmosphere would gather and thicken. It would be like a bustling city, full of air molecules. But as you venture towards the edges, things would start to thin out. The atmosphere would become scarce and very thin. So breathing along the edges would be quite a challenge, and the edges would be a tough neighborhood for life to thrive. Moreover, a thinner atmosphere means less protection from the sun's radiation and solar winds, so corners and edges would be extremely dangerous for humans. Of course, this is all just a playful exploration of what could be. Our Earth loves its spherical shape, and that's a good thing. But there's no harm in imagining wild and wonderful possibilities, so keep your imagination soaring and continue to marvel at the marvels of our amazing planet. However,
you're on a plane heading to an important astronomy convention when you see a large figure outside your window that eclipses the whole sun. You spit out all of your coffee, and everyone in the plane stares outside in shock. You then notice that it has rings like Saturn. You were supposed to fly to Japan, but you're forced to land in California. As soon as you land, you look up in the sky and see some more giant planet-like structures floating around in the sky. Everyone is taking pictures and trying to figure out what's going on. Suddenly, you notice a huge ball of fire crashing down near the airport. Everyone scrambles for safety, and luckily, it ends up in the middle of the runway with no one around. The bad news is, there's no more runway for planes to land. Everyone huddles together for safety, and more large objects appear in the sky. All communications have ceased or broken down, since these large objects have ruined all the satellites. Some scientists nearby mention that these objects are the planets of the solar system going within the same proximity as our moon. Mercury and Venus look like moons, but Saturn is occupying a lot of sky real estate. You tell those scientists that you're an astronomer. They invite you to join them on a trip to Antarctica, to the observatory station in the South Pole. They need every mind to help solve this mystery. You get on a ship with the coordinates set to Antarctica. The waves are extremely rough for typical daylight and non-stormy weather. You finally make it to the shore of the continent after a few days and have to get in a snowmobile all the way to Amundsen Scott South Pole Station. Over here, you and a group of scientists will figure out what's going on. You weren't prepared for the freezing temperatures, even though it's July. You arrive at the station and see all your fellow scientists running around with paperwork and blurting out stuff about planets orbiting our atmosphere. You arrive at the conference room where the lead scientist explains what's going on. One by one, the planets are coming closer to us until they're aligned with the moon, but they still don't know why and how. Venus arrived first, and now Saturn is getting closer. The moon is around 240,000 miles away from Earth, and it affects the tides of the oceans and seas with its gravitational pull. Since water is less dense than land, we can see the tides change. So high tides occur when the Earth is pulled towards the moon. And since the other planets are coming closer to Earth, the gravitational pull is erratically changing. In a couple of hours, Saturn will be in the same distance as our moon. You head to the large telescope and observe the planets. Any plane or helicopter won't fly properly and won't have the proper radar technology to help it. You keep observing and notice Mars getting closer to Earth. You get news that tidal waves are rising very often now, and some island nations are even being washed away. Good thing they got evacuated beforehand. With Mars closing in, you notice Neptune also getting closer. You can feel the gravity on Earth fluctuate with every step you take. You report your findings to the lead scientist, and the only way for survival is to quickly build bunkers far away from oceans and seas that can host many people before the other planets close in. A team of engineers arrive and start building. Wave after wave of survivors come and settle into the bunkers, practically built overnight. With every hour, more planets are getting closer. Mars and Neptune have already settled in, with Mercury, Venus, and Saturn. Pluto and Uranus are now visible to the unaided eye and are making their way towards Earth. The gravitational pull is getting completely out of hand. The snow in the Antarctic desert remains floating for several seconds whenever someone walks on it. You can jump a lot higher. It's now nighttime, but the sky isn't dark as usual. The planets are reflecting a lot more sunlight than our moon. It's barely visible now. With more observations, you notice comets and meteorites flying very close to our atmosphere. Some are even crashing down on Mars and Neptune. Everyone can see it from Earth. Other space debris also finds its way into Earth's atmosphere. But you notice something strange. The planets are now orbiting Saturn. You check your calculations and find out that the planet's positions are now aligned with Saturn's orbit. That's because it has the biggest mass among all the planets. Saturn's rings are made up of ice particles, some as large as a bus and others as tiny as pebbles, but they're all crashing and interfering with the other planets. No one can feel the orbit shift at first, but later you can start to feel it. With this happening, earthquakes and volcanoes are bound to happen. This is why everyone, including yourself, is packing up and ready to flee. Antarctica has dozens of volcanoes hidden beneath the frozen ice. Some are underground, while some are right on top. Saturn's gravitational pull is much stronger than Earth's gravitational pull on the moon. This will cause the inner core to react a lot more and kickstart those earthquakes and volcano eruptions. Everyone packs up super quick and heads to the choppers to fly to South Africa. These choppers were designed to have a direct course without the need for radars to guide them. You arrive in South Africa, which is mainly covered in water. The chopper takes you closer to the center, and then you travel to the Sahara Desert. The plain surface with nothing around it will be the best option for safety. But you look up in the sky and see another planet closing in. It's Jupiter, the biggest planet in our solar system. If Earth were the size of a grape, then Jupiter would be the size of a basketball. It's approaching quickly. Many of the other planets automatically make way for it, including Saturn. You're on the road heading to the Sahara, even though it'll take days to reach by car. The sky is dark during the day, since most planets are blocking the sun. You finally make it to the Sahara Desert with other scientists, and to your surprise, a whole city was erected in just a month when the planets started showing up. You settle in your dorm, but still have a lot of work to do. A couple of days later, Jupiter breaches the atmosphere and completely eclipses us. But Earth is now rotating around it, and it's much quicker than orbiting the Sun, since Jupiter is smaller. But since Saturn is also big, Earth keeps getting tossed from orbit to orbit, like two people playing a ball game with each other. So with that happening, people on Earth are experiencing different gravitational pulls from time to time. The tidal waves keep getting stronger, and volcanoes are erupting everywhere. Since the Earth's core is getting hotter, the temperature on Earth is also changing. And with a lack of sunlight most of the time, much of the plant life is having a hard time trying to keep up. Crops are harder to plant with natural sunlight, so people are turning to artificial lighting and greenhouses. Air and space travel are impossible. The International Space Station is completely ruined, along with the satellites orbiting space. That's why cell phones and the internet can't work. Gravity is even more dysfunctional than ever. 6 months later, humanity has found some way of coping with the new normal, but things are constantly being updated. The number of hours in a day has changed, as well as days that compose a week. This used to be measured with the moon phases. A month used to be the moon achieving all phases from none to full moon, and so on. But Earth's moon has disappeared with the cluttered, disorganized planets.
This may look like a scene from a cool sci-fi movie or an astonishing painting, but it's actually real-life footage of Mars, the very planet known for its bright rust color. Layers of rock and dust cover the planet's surface. They consist of iron-rich minerals. That's why dust on Mars is mostly iron oxide. It floats in the atmosphere and creates an orange-red haze around the planet. But Mars has some even more amazing things, like these blue speckles on its surface. They look like a wind-sculpted sea of dunes around 19 miles wide. Astronauts saw these dunes at the northern polar cap of the planet. That's a region that covers an area approximately as big as Texas. The blue dunes, formed by winds, are shaped like long weaving lines. The winds on Mars are relentless and strong. They turn the barren surface of the planet into terrains of grand beauty. These winds are influenced by many different factors. For example, temperature fluctuations to the way the planet's atmosphere circulates. The atmosphere is thin on Mars. That's the reason liquid water most likely can't exist there for any long period of time. That's why, even though Mars is only half the diameter of our planet, it has the same amount of dry land as Earth. A thin atmosphere is also the reason why wind needs to be exceptionally strong and fast to move the sand and form such shapes as these dunes. Winds usually move at 10 to 20 miles per hour on Mars. Anyway, even though the image looks pretty colorful, the dunes aren't actually blue. The bluish patches represent colder parts, while the warmer regions are yellowish-orange. The images were part of a set of photos released to celebrate the 20th anniversary of Odyssey, a spacecraft orbiting Mars. Mars has numerous sand dunes in different locations all over its surface. Some of them formed a billion years ago, like the ones in the Valles Marineris region. They haven't changed because both the atmospheric pressure and wind patterns there have remained the same. But some things do change. For example, some dunes get covered with frost. Here, the main dune has a series of dark patterns. It may be because frost comes and goes, depending on the season. Mars has 4 seasons, just like Earth, but they're twice as long as ours. It's because Mars needs around 2 Earth years to orbit the Sun. Seasons are harsher in the south of the planet than in the north. During southern winter, the planet is farthest away from the Sun. Mars moves pretty slowly, and its orbit is elliptical, different from the orbit of Earth, which is almost circular. Spring on Mars is a season with plenty of dust storms that start in one part of the planet and, eventually, turn into huge storms. They become so large, they blanket the entire planet. Each planet of our solar system has something that makes it special. Jupiter, for example, is not only the largest planet, more than twice as big as all other planets combined, but it also has the biggest ocean in the solar system. Jupiter is made of similar elements to the Sun. They're mostly helium and hydrogen. In the deeper parts of the planet's atmosphere, temperature and pressure increase. That's why the hydrogen gas gets compressed and turns into liquid. That gives Jupiter the biggest ocean, but it's made of hydrogen, not water. There's also a theory that somewhere halfway to Jupiter's center, the pressure increases so much that electrons start getting squeezed out of hydrogen atoms. This allows the liquid to conduct electricity as effectively as most metals do. Jupiter is rotating fast, which creates electrical currents and generates a strong magnetic field. But as a gas giant, the planet doesn't have a firm surface. The planet's swirls and stripes are cold, windy clouds of water and ammonia. Jupiter also has the iconic Great Red Spot, which is an insanely large storm with crimson-colored clouds spinning counterclockwise. Winds there are way faster than any hurricane on our planet. The Great Red Spot has slightly changed throughout time and is currently bigger than our planet. It's 1.3 times as wide as Earth. Scientists have discovered that its roots extend more than 200 miles into Jupiter's atmosphere. A regular tropical cyclone we see on our planet can only extend 9 miles from the top to the bottom of the storm. These days, the red spot is becoming smaller and taller at the same time. Jupiter also has dozens of moons and a couple of rings, but unlike Saturn's rings, these are quite faint and mostly made of dust, not ice. Also, there's a salty ocean under the surface of Jupiter's biggest moon, Ganymede. It's hidden below a thick icy crust. It's likely to contain more water than all surface water reservoirs we have on Earth combined. The theory says this ocean is around 60 miles deep, 10 times greater than the deepest point of our planet's oceans. Jupiter and Saturn contain 10 million tons of precious stones. The pressure inside these planets' atmospheres can actually turn carbon into small pieces of diamonds. If you put these diamonds under extreme temperatures and pressure, they can melt. This would probably result in some sort of diamond rain. In the beginning, our solar system was just a swirling cloud of gas and dust. It eventually developed into a spinning disk with the central star in the middle. Almost all planets in our solar system move counterclockwise around the sun. Venus is the only planet that rotates in a clockwise direction, and Uranus rotates on its side. These planets are most likely different because long ago, huge asteroids collided with them and kinda knocked them off their course. There's a chance Venus could be a habitable planet. It's definitely not a place you'd want to live now, not with its sulfuric acid clouds and tremendous atmospheric pressure. It's 90 times greater than that on Earth. Add here insanely high temperatures. The conditions on Venus are very unfavorable for people. At 863 degrees Fahrenheit, Venus is hotter than Mercury, even though it's further away from the sun. This happens because there's too much carbon dioxide in Venus's atmosphere. It traps heat, which causes the temperature to rise way higher than it's supposed to. But simulations showed that around 700 million years ago, Venus might have been a nice place with moderate temperatures and liquid water. Those conditions were slightly similar to those we have on Earth now. Uranus is not a gas giant. It's actually made of ice. The atmosphere contains methane, which makes the planet look blue. It has 27 moons, 2 sets of rings, and lots of ice in its atmosphere. A day on Uranus lasts just a little bit over 17 hours. That's how long it takes the planet to complete a single rotation on its axis. But its tilt is so pronounced that most of the time, either one or the other pole is pointed toward the sun. That's why the daytime length at the North Pole is almost half a year, and a year on Uranus is as long as 84 years. If you lived on Uranus closer to its North Pole, you'd be able to see the sun in the sky for 42 years. That would be the summer. After this, the sun would go down, and you'd have to live the next 42 years in the darkness. It'd be the winter on the planet. Neptune is the most distant and the smallest of the gas giants. The gravity on the planet is similar to the one we have on Earth, but you wouldn't be able to stand on Neptune's surface. It's gas, not solid land. Triton, the biggest of the planet's moons, orbits Neptune in a very unusual way. It moves backward compared to the rest of the planet's moons. Triton is also slowly spiraling inward toward Neptune. One day, billions of years from now, it's likely to get torn apart by the planet's gravitational forces and become just a ring around Neptune. This ring will continue being pulled inward until it eventually crashes into the planet. Pluto is a dwarf planet, and a year there lasts 248 Earth years. But even though it's not even a planet, Pluto still has several interesting things to offer, like floating mountains. Pluto's nitrogen glaciers carry countless isolated hills, each up to several miles across. They're likely to be fragments of water ice from the dwarf planet's surrounding uplands. Nitrogen ice is denser than water ice, so scientists think water ice hills float in a sea of frozen nitrogen, just like icebergs in the Arctic Ocean here on Earth.